Okay, so what we're going to do today with these notes, really you guys already know this stuff, okay? So we're taking a couple skills that we already know. Skill number 1, how to deal with point charges. And we're mixing it with another skill that we already know, vector boot camp. Thank you for that cheer right there. Okay, so we're going to mix those two things together. Guys, it's not really anything new, okay? But it's a lot going on, so we'll do an example with force and an example with fields, and then on the back we'll do an example with potential, okay? Now, you got to keep in mind everything we are doing with this is for point charges only, okay? The equations only applied if we have point charges. All right, so first question here. Calculate the net electrostatic force on charge Q3 in the figure due to Q1 and Q2. Okay, so first thing I want you to do is draw an FBD on Q3.
What video, Mr. X?
Okay, draw it. Okay, so hopefully you've drawn your FBD, okay? And so what I like to do when I do an FBD for point charges is just deal with two at a time, okay? So the force on this due to that is going to be a repulsive force in that direction. Okay, by the way, side note, the force on that due to that would be equal and opposite, right? Okay. Now, I'm going to cover this one up. This is going to be an attractive force in this direction. Okay, so now we've got our FBD done. And let's label these. I like to say something like this: force on 3 due to charge 2. And force on 3 due to charge 1. What's that? For Q2?
For due to the charge.
Oh, yeah.
What are you actually writing?
I'm just saying the force on charge 3 because of charge 2. So I just put a 3-2. It's just my way of keeping track of what force is what. Okay? Alright, now we just have to use Coulomb's law twice. One for that and one for that. Okay, then we have to do vector addition, which we haven't done in a while, so we'll review that real quick. Alright, so do Coulomb's law twice. F3-1 equals, and you're going to do Coulomb's law. And then down here, F3-2 equals, and we'll do Coulomb's law again. So what I want you guys to do is get both forces and then check and see if you're right.
What video, Mr. X?
Okay, make sure you pause the video and do it on your own, okay, or you will not be getting out of this what you need. Okay, here's how you do it. I'm just going to write out K. We know it's 9 times 10 to the 9th. And remember, we drop all the signs in Coulomb's law. So if anything's negative, like Q1, we'll drop the sign. 65 times 10 to the -6th. Okay? So microcoulombs, all you have to do is write the number and tack on a to the -6. Next one. I got a -86 microcoulombs, so I'll just write an 86 times 10 -6. Then I've got to divide by r squared. Alright, and so this radius is 0.6 meters. Make sure you convert to meters from centimeters, and you'll get an answer equal to 140 newtons if you punch that into your calculator correctly. Okay, just Coulomb's law. Alright, this one, similar. K, same Q. All right, then we'll do the other charge. And this time we're going to divide by 0.3 squared. If you punch that into your calculator, you get 325 newtons. And I probably rounded those a little bit. Okay. And now comes the part we haven't done in a while. The vector scorecard. Yay. That was a little bit weaker of a cheer that time, but I'll take it. Okay, so there's an X team and a Y team. And remember, each vector gets an X score and a Y score. And then we simply add the X's, add the Y's, and that gets us our resultant. It's a really easy way to add vectors, guys. Okay, so let's deal with the easy vector first. That one right there. That is scoring only points for what team? The Y team. Negative points or positive points? Positive 325 points. So there's no X component, so we put a 0. Then over here, positive 325. Okay, that's easy. All right, now this one over here, this has got a horizontal and a vertical component, like that. You've got a 30-degree angle down here. That means a 30-degree angle right here. Okay, so we know this hypotenuse, it's 140. And so we can get these two components. So the Y component is going to be 140 times the sine of 30. And X is 140 cos 30. And if you punch those in, this comes out to 70, and this comes out to 121. Okay, now how I do my vectors, really, you know, this is a negative 30. Your calculator thinks it's a positive 30. Okay, so you're going to have to put the signs in manually over here. So this 70 right here really needs to be a negative 70 because it's downward. And the X component is a positive 121. Should be. The horizontal is positive. The vertical's the negative one, the Y component. So this is 121 positive. Okay, so now we need to get the resultant score. It's going to show you how to build your final vector. So we get 121 newtons down, positive, or sorry, across to the right. And then here, this is positive 255. My baby blue G2 is almost out of ink. It's sad. It's my favorite G2. I'm going to retire him for a minute. Okay, give him a rest. All right, now, last step to vector addition, if we are trying to find a resultant vector, is to take our final components here. These are our final coordinates, and build our new vector. Okay, now just looking at this, what direction should the F-net be? Kind of like right there, right? Between those two? Okay, so let's see if we got this right. So I always do the X first, so I'm going to go over 121. Alright, and this is just a sketch. You don't have to necessarily draw it to scale. We kind of try. And then I'm going to go up 255. And now I simply have to find the value of that vector. Right there. Okay, so we're going to use good old what?
A squared plus B squared equals C squared.
Yep, A squared plus B squared equals C squared Pythagorean theorem. Okay, so if you do that, I know you guys know how to do that. So I'll just tell you what it comes out to be. It's 282 newtons for the hypotenuse. And then we have to find the angle, because it's a vector, so we can't just have the magnitude. We got to give theta. So you get to pick your favorite trig function to do it. Since you know all the sides, you can pick any.
Cosecant.
Not pick cosecant. Okay, so guys probably know that my favorite trig function is tangent. Okay, tangent theta is equal to 255 over 121. Okay, so let's punch that into our calculators. And we want to inverse tangent. To undo a tangent and get theta, you second tangent. 255 divided by 121. Oops, radians. I bet one of you put my calculator in radians. You know who you are. I'm glad that made the video because it reminds people. Isn't that embarrassing? Actually, no. It wasn't, because I noticed that it was radiant. If I had put it down there, then it would have been embarrassing. Yeah. Okay, so theta. So I'm going to put at 64.6 degrees. Okay, and if you just report an angle like that, you're reporting it from 0. Okay? All right. Questions on that? Anybody? Real questions? Yes.
Will you go over up at the top how you got 140? Where in 140?
The 140? So K is 9 times 10 to the 9th. So if you punch all that in, you get 140 newtons. I just didn't punch it in to save time. But punch it in on your calculator, you'll get 140.
No, I believe you. I was just, so, and then how is that put into, like, the other stuff to get the X and Y list?
So we broke it into X and Y components right here.
Oh, okay.
So we broke it into that and that by doing sine and cosine. And if you, I can show you how to do that here in a second if you need help with it. Okay, now check this out, guys. Here, same type of situation, but you are asked to deal with field instead of force. Okay? Now, E field, is that a vector or scalar? Does direction matter for E field? Yes, it does. WWPCD, that's our E field rules. Okay? So on this one, I'm going to show you guys how to set it up, and then I'm going to let you work it on your own. Okay? And I put the answers down there at the bottom. Okay, so here's what you do. Check it out. Calculate the total E field at point A and at point B due to these two charges. Are there any charges at point A or B?
No.
No. Okay. All right. There's nothing there. So there are no forces at A or B, but there's still a field at A and B. Okay, so draw the field vectors at A and B. It's kind of like doing an FVD, but you're drawing the field vectors instead. Okay, so at point A, let's look at this. This is going to create a field, WWPCD. I'm going to draw that. Okay, and I'm going to label that E2. Okay, now this one here, it's a negative charge, so the E field due to that is going to be like that. I'm going to call that one E1. And you're simply going to find the values of the E field, and you're going to do vector addition just like this. Okay? So it'll be a good test to see if we've retained this. So that's actually part of your homework, is to come back with this part done. Okay, I'm not going to show you how to do that or put that in the video. Okay, question? Yep.
So for A and B, we just use the charge.
Okay, so for an E field, you don't need a second charge. What's the formula for calculating an E field due to a point charge? KQ over R squared. All right, so KQ over R squared. You're going to have to do it twice. All right? Yep.
For point B, are we going to be using stuff from the negative charge down there and what we got from point A?
Okay, so for point B, we don't care about what's happening at A. So let's draw the E field at point B right here so we have it done. Okay, so E field due to that is going to be WWPCD, that's E1. Okay, and then the E field due to this, let's draw a reference line. That's E2. Okay, and here's a hint so you guys don't waste time. What's going to happen to the Y components of this? Those are going to cancel because this distance is 40, which makes this distance also 40, and these charges are equal but opposite sign, so you're going to get the same values. That you don't even need to do a vector scorecard for this one because the Y's cancel, and what do the X components do? They're working together. They just add. Okay, so really you just have to get one value multiplied by 2. So point B, that's easy. That's going to take you like this much space down here. Point A, that's not easy. That's going to be a big mess like this. Okay? All right, any questions on that? How to finish it? Okay? Yeah, radius is different from what you had above. Okay, let's turn over to the back. Oh my gosh, Mr. Hicks, how mean. You gave me the same diagram again to torture me and make me do the same problem. Okay, check this out. Potential. All right, now we're dealing with potential. Potential is significantly mathematically easier. Why? Well, for one, there's no inverse square, yeah, so that makes it easy, but there's another reason. Oh yeah, it's scalar. Okay, no vectors, no angles, no sine, no cosine. Okay, so we want to calculate the potential, the voltage at A due to these two charges being present, and then we want to calculate the voltage there. Okay, so it says you must use the summation equation. That simply means you are going to use this. You're going to do the sum of the voltages. So KQ over R. And then let's put a 2 right there. That's Q2 down there. It's pretty small. And then we're going to add that to the voltage due to this one. K Q1 over R. No squareds, no angles, okay, but we do have to leave signs in for this. On the other side, it was all absolute value. Okay, so the signs matter, and let's plug in some numbers. All right, so I'm just going to leave that as K. And then the value of Q2 is 50 microcoulombs. Radius of 0.3. Okay, that's your 30 centimeters right there. All right, now the other one's negative. So we'll do K and negative 50 times 10 to the negative 6. and resist the temptation to square these things. Okay, so punch that into your calculator. Let's see what we get. Okay, so if you do that, you get 7.5 times 10 to the 5th what? Unit for potential. Volts.